binary representation, n integer 4, n fractional 8 of these numbers. We have some fraction numbers. We want to convert them into binary. Now here they put n integer 4, n fractional 4. This actually means the integer numbers are 4 bit. Like for example 0, 0, 0, 0. Then point fractional numbers are 8. 0, 0, 0, 0, 0, 0, 0, 0. That's what this means. We have to have 4 integer numbers, 4 integer bits, and 8 fraction bits. Okay, so now let's go ahead and solve one by one. Let's look at the A part. The A part we have 0.355468750. And when we are converting a decimal number to a binary, we deal with the integer number separately and the fraction number separately. Here the integer number is 0, so we can just keep it as 0. And then the fraction number is 0.35, this number. So what do you have to do for the fraction? So here, since we only have to do the fraction, let's forget about the integer number, because for the integer number at the end, like we will just put 0, 0, 0, 0 point, and what comes after, that's what you have to find out. So here we have 0.355468750. To find out the binary equivalent of a fraction number, what we do is we multiply this one by 2 continuously until it becomes 0 points, like the point after point if we get 0 completely. Until that we keep on multiplying. So here if I multiply this one by 2, I get 0.710937, and we have to look at the value before the decimal point, that is 0 here. So that comes, we put that one right here. And then the next what we have to do is we grab this value 0.7109375 and then multiply that one by 2, and that gives us 1.421875. And here we have to look at what number we have before decimal point, that's 1. So here we put 1. Then after that we only grab the value that after decimal point, that is in this case 0.421875. So we grab that one only, we neglect the values before the decimal point. Here is 1, we neglect that, only the values after decimal point. So this is 0.421875, and then multiply that one by 2, that is equivalent to 0.84375, and here we have 0 right here, so that comes right here. And then the next one is 0.84375, multiply that one by 2, that gives us 1.6875. Here the value we have is 1, so that comes right here. Then we only take the value that's after decimal point, that is 0.6875 in this case, and then multiply that one by 2, that gives us 1.375. and here we have 1, so that one comes here. And then the value after the decimal point is 0.375, multiply by 2, and that gives us 0.75, and that is 0 right here, so that one comes here. Then 0.75 multiplied by 2, that is 1.5. Here we have 1 comes here. Then we take the value of decimal point, that's 0.5 in this case, multiplied by 2, and then that is 1.00. So here we have a situation that is, here we have 1, and we got a situation that is 0, 0, like we made it completely 0. So we stop right there and we look at how many numbers we reached already. So 1, 2, 3, 4, 5, 6, 7, 8. So we have already 8 bits. Okay, this should be going from top to bottom. So we should read from top to bottom. so we already have 8 bits, so we don't have to do anything else. For example, let's say you reach this, you stop right there, 0 1 0 1 1 0 1 1. In this case we already have 8 bits, but let's say you only got 7 bits and you end up with 0 0 right here. What you have to do is, to make it to 8 bits, you just add one more 0. But here we already have 4 bits here. 4 bits is this integer, that is 4 bits, 0 0 0 0 0. And then fraction we give 8 bit, that is 0 1 0 1 1 0 1 1. Once we reach there, we are done. That's the answer for the first question, the A part. Okay, now let's look at the B part. I go to a new page and do that. In the B part, we have 0.34765650. 0.34765650. Okay, so here again, the whole number, the integer value is 0. So that's going to be just 4 zeros we put, because they requested 4 bits for integer. So we put 4 bits. And then now what we have to do is we have to convert the fraction into a binary. To convert the fraction into binary, again, multiply this one by 2 until we get the 0 0 situation like this. If we get it, it's okay, but if we don't get it, we stop at 8. Like here we had exactly 8. Let's say if it keep on going, like if you have even more than this, even if we have more than that, we stop at 8, because that's the one required for the question. They require 8 bits only, so we stop at 8 bits and give the answer. We don't have to go one more step if we have situation that we have to do something more, since only 8 bits are required. Okay, so let's do this. So here we multiply this one by 2, 0.34765650 multiply by 2. That gives us 0.6953125. And here we have a 0, so that one comes here. Then 0.6953125 multiplied by 2, that gives us 1.390625. That is one, that is 1 in front right here, so 1. And then 0.390625 multiplied by 2, and that gives us 0.78125, and here we have 0. Then 0.78125 multiplied by 2, that gives us 1.5625, and here we have 1. Then here we have to look at the value after decimal point, that is 0.5625. 25 multiplied by 2, that is 1.125. That is 1 right here. Then 0.125 multiplied by 2, that is 0.250. That is 0 here. And 0.250 multiplied by 2, that is 0.5000 here. 0.500 multiplied by 2, that is 1.00. Here we have 1. And we already got a 0 0 situation, so we stop right there. We don't have to do anything else. Now here also we end up with exact 8 bit. We read from top to bottom. 0 1 0 1 1 0 0 1. We already have 8 bits, and it exactly entered like this. So this is the final answer. Okay, we don't have anything else. This is the final answer for the B part. Now let's look at the C part. The C part, we have 0.5390, 0.25390, then 250, 250. Okay, so here also, if you look at the integer value, that is 0, so we put a false 0 for that. And then fraction value is the one we have to convert. So to do the conversion again, multiply by 2 until it becomes 0. Becomes like 0.00, like this. If we don't get it, we stop at 8 bit. 3906250 multiplied by 2, that gives us 0.5078125, and here we have 0, so that one comes here, and then 0.5078125 multiplied by 2, that gives us 1.015625, and here we have 1, that one comes here. Then you only take the value after decimal point, that is 0.015625 multiplied by 2, and that gives us 0.03125. Here we have 0 in front, so it comes here. And 0.03125 multiplied by 2, that gives us 0.0625. And here we have 0, here comes 0. 0.0625 multiplied by 2, that gives us 0.125. Again, here we have 0. Then 0.125 multiplied by 2, that is 0.250. And here we have 0 right here. And 0.250 multiplied by 2, that is 0.500, that is 0 right here. And 0.500 multiplied by 2, 1.00. Here we have 1, we put it right here, and we stop right here because after decimal point we have 0, 0. We stop it right there. And read from top to bottom. Make sure we have 8 bit 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 bits exactly. So we don't have to do anything else. We just write it exactly like this: 0, 1, 0, 0, 3 more zeros, then 1. This is our final answer for the third part. Okay, and that's how we can convert a decimal fraction into a binary fraction. That's it for this video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.